Moleculand. It is where atoms bond, electrons dance, and chemistry comes to life. Today, in the world of Moleculand, we follow Alco the alcohol as they explore what makes alcohols unique.
Hi everyone, my name is Alco. And I got this OH thing stuck to me. But people keep calling me an alcohol. But what does that mean?
That's a great question. Your organic compound contains one or more hydroxyl groups attached to a saturated carbon atom. This group gives you your characteristic polarity and hydrogen bonding affinity.
Oh, so this OH thing makes me special?
Exactly. That's what gives alcohol their polarity, give their ability to form hydrogen bonds, and many of their physical properties, like higher boiling points compared to alkanes.
And that's why small alcohol can mix well with water, right?
Correct. The smaller the molecule, the more soluble it is in water. But as the carbon chain grows, solubility decreases because the molecule becomes more non-polar.
So Alco learned that the structure of alcohols, primarily the OH group, determines their physical properties such as boiling point and solubility. Alcohols are organic compounds with an OH group attached to a carbon. This group makes alcohols polar, capable of hydrogen bonding, and generally more soluble in water, especially the smaller one. Now, let's see how alcohols are named.
Whoa! Why is there so many alcohols? How do chemists name us all?
That's where nomenclature comes in. Chemists follow the IUPAC rules to name alcohols systemically. First, the longest carbon chain that includes the OH group, then replace the E at the end of the alkane name with OL. And don't forget to number the chain so that the OH group gets the lowest possible number.
Can you give me an example?
Sure. CH3OH, methanol. So to explain, it determines the IUPAC name of methanol. We begin by identifying the structure of the compound. Methanol contains only one carbon atom, so its parents hydrocarbon, methane, and next we look for the functional group present in the compound. Since methanol has hydroxyl group OH, it belongs to the alcohol family. According to the IUPAC naming rules, alcohols are named by replacing the E at the end of the alkane name with OL. When we apply this to rule methane, the name becomes methanol because there is only one carbon atom. The hydroxyl group is automatically attached to it, so there is no need to indicate that its position. Therefore, the IUPAC name of the compound is simply methanol.
When more than one OH group is present, prefixes like diol or triol are added. For example, glycerol is propane 1,2,3-triol. And now, let's discover the importance of alcohol to our daily life.
Hello everyone, I'm Medic, here to show that alcohols aren't just in beverages, they're vital in medicine and industry too.
Really? Aren't alcohols dangerous?
Some are, but many are useful too, like ethanol, found in drinks and used as an antiseptic and solvent. Methanol, used in fuels and industry, but toxic if ingested. It turns into formaldehyde and formic acid, which can cause blindness or death. Isopropyl alcohol, found in rubbing alcohol and hand sanitizers. Glycerol, a non-toxic triol used in cosmetics, medicine, and even food products.
So some alcohols help heal, then others can harm.
Exactly. It depends on their chemical structure and how the body processes them.
In medicine, alcohols are important. Ethanol disinfects, isopropyl cleanse, glycerol soothes, but methanol is toxic. Always remember, structure determines safety function. Each alcohol carries different strengths, risks, and roles. Even in medicine, chemistry shapes destiny. Now that Alco knows their family and name, it's time to learn how alcohols react.
Let's explore some of your transformations, Alco. When heated with an acid catalyst, alcohol loses water to form alkenes. This is an elimination reaction. Substitution, the second one, the hydroxyl group can be replaced by a halogen atom to form an alkali. Oxidation, primary alcohols, aldehydes, then carboxylic acid. Secondary alcohols, ketones, and tertiary alcohols. They generally do not oxidize easily.
So I can become an alkane or halides or even transform into acids and ketones. Yay!
Yes, exactly. Alcohols are versatile. That's why they're central in organic chemistry.
So basically, alcohols can undergo three major reactions. The first one is dehydration, which removes water and makes it into an alkene. The second one is substitution, which replaces the OH with halogen and then it turns into a halide. And the third one is oxidation, which gains oxygen or lose hydrogen and it results into a new compounds. These reactions show how alcohols can change form depending on conditions. Each reaction changes the structure and properties of the molecule, and that's the essence of organic transformation. But reactions don't just happen in test tubes or laboratories. They happen in our bodies too.
Inside living systems, oxidation and reduction or redox reaction help cells release and store energy.
Like how our bodies use food to make energy.
Exactly. In cells, special molecules like NAD+ acts as carriers. When alcohols are oxidized, NAD+ is reduced to NADH, storing energy that cells use to make ATP, the body's energy currency.
This happens in your liver too. Ethanol is converted to acetaldehyde and then to acetic acid, releasing energy but also forming toxic intermediates if in excess.
Alco has traveled far, from discovering structure and names to reactions and life processes.
I learned so much. My OH group makes me special, reactive, and useful.
And remember, kids, chemistry explains not only how molecules behave, but also how life itself functions.
That's right, whether in medicine, energy, or daily life, alcohol plays a vital role.
And now, let's summarize everything we've learned today. First, we talked about the structure of alcohols, wherein they have an OH group attached to carbon. The second one is we talked about their properties, wherein they form hydrogen bonds, they're polar, and dissolve in water. In the third one, we talked about nomenclature, wherein we use the longest chain and lowest OH number and all ending. In the fourth one, we talked about medical importance, wherein ethanol, isopropanol, methanol, and glycerol have major industrial and health roles. And the fifth one, we talked about the reactions of alcohol, wherein they can undergo dehydration, substitution, and oxidation. And the last one, in living systems, redox reactions involving alcohols and NADP plus power cellular energy. And so, our journey ends, but the wonders of chemistry do not. Thank you for joining us in Moleculand.